Can you hear me? Hello? Can someone just type on the chat if you can hear me? Yeah, okay, fine, thank you. So, uh, good evening and welcome to today's session. So, today we'll be talking about introduction to alternative fuels. Last week we talked about sustainability, introduction to sustainability. So, and we discussed a few questions. So, we will be starting out with answers to those questions. I think there were a few answers already, but we'll discuss about how to solve. I mean, there is nothing to solve essentially, just the answers we'll discuss. And then we'll go to what are alternative fuels, the three generations of biofuels 1G, 2G, and 3G. Okay, the need for alternative fuels or biofuels. Then we will talk about electric vehicles, the pros and cons. Okay, and then the biofuel policies in India, and then the other side of 1G ethanol. That is the first generation ethanol. So we'll be saying what is this 1G ethanol first, and then we'll be talking about the other side, the impacts of 1G ethanol, so to speak. And then we'll finish with questions for this week. All right. So, we'll proceed with the answers to the questions from week 1. So, the first one is you have the intersection of social and economic, that is equitable, social and environment, that is bearable, environment and economic, that is viable, and then D, that is the intersection of all three, it is sustainable. All right. So, the next question is sustainable development is said to occur when, right? So, what is sustainability? It is meeting the needs of the present without compromising the ability of future generations to meet their own needs. So, the meeting the needs of all stakeholders is important, and it is also important to leave resources for the future. So, the correct answer is C. The needs of all are taken care of, including intergenerational justice. All right. The third one was, which among the following statements are false? So, the three dimensions of sustainability, they are economic, environmental, and social. So, in option A, it was given as economic, education, and environmental, which is not right. So, instead of education, there should be social. So, the other options had, I think, the additional governance dimension by a few researchers, and then the dimension consists of the composite indicators, and composite indicators are obtained by aggregating individual indicators. So, the answer is A. Right, that statement is false. Then number 4 was what is the innovation chain useful for? It is useful for introducing new technologies in the market because it is a process to be followed to convert an idea into a marketable product. So, if you want to introduce any new technologies or any new services in the market, you have to go through the innovation chain basically. Number 5, in the innovation chain, the term research and development refers to. So, if you recall, the innovation chain had so from the idea you go to relevant basic research, then to applied research, and then development and design, and then engineering for manufacturing, then manufacturing, marketing, and then product. Okay. So, out of this, research refers to relevant basic research and applied research. Okay. And development refers to design and development and engineering for manufacturing. So the right answer is D. All of these, like basic and applied research, and design and development, and engineering for manufacturing. This is what is included in research and development. Next is which of the following statements are true? So we had a few options about the profit based and the triple bottom line approach. So return on investment is the most important parameter in a profit based approach. So shareholders requirement are the most important in the system, but in triple bottom line it has to take care of all stakeholders. That is, you have the people, the planet, and the profits, the three P's of corporate sustainability. So greenhouse gas emissions are one of the most important indicators of a company's sustainability. So the true statements are A and B. That is, in the profit-based approach, shareholders are given the most importance, and triple bottom line approach takes care of takes care of all stakeholders, right? But statement C said that greenhouse gas emission is not part of the triple bottom line approach, so that is false. Number 7 was the application based question regarding the industry that produces a product Z and harmful chemical X as an effluent. So what the company must do is, since X causes harm to both humans and marine ecosystems, they have to build a treatment plant for X. And the people who are handling this chemical X, the employees, the workers in the industry, they need to be provided with proper protective equipment like gloves, masks, and so on. Okay, but even otherwise, even after taking all these precautions, they still run the risk of contracting cancer, right? Of getting cancer because of prolonged exposure to chemical X. So a good health insurance is also a must to be provided to the employees, so that they are taken care of. Okay. But if you recall, in the option number D, it had said that we have to increase the cost or increase the price of the product to cover for these costs. But you have to recall that in the triple bottom line approach, even the customers are part of the cycle, right? So because of that, we can't really do that. We can't really increase the price. So the correct option is option number C, that is provide protective equipment and insurance to workers, install a treatment plant, and market product Z as a sustainable product to improve company reputation and sales. Right. Then question number 8 was the small numerical about the number of hospital beds per 10,000 people in Bangalore. So the formula was already given to you, the normalized indicator value, which is actual value minus the minimum threshold value divided by maximum threshold value minus minimum threshold value. So just apply it here, and then you get an answer of 0.14. So compared to other cities, at least this indicator is only 14% sustainable. That is the meaning of this normalized indicator. Okay, and there is an abysmal number, so to speak. Okay, so we are at the end of the previous week's answers. So in case you have any doubts, are you not able to hear me? Hello? Yeah, can someone confirm? Okay. No, someone had just commented that I'm not audible, so that's why I asked. Okay. Do you have any questions regarding the previous week and what the question answers that we just saw? If there are no further questions, I'll proceed with this week's lecture. I'm assuming there are no questions, so okay, I'll proceed with this week's lecture, right? Okay. So introduction to alternative fuels. All right. So what are alternative fuels? So you have petroleum, right? That is the main fuel that you are using in transportation. Okay, and then you have natural gas. Okay, so these are fossil fuels. That is, they're derived from like fossils. That is, plants or animals that died millions of years ago, and then they are converted into this fuel because of the pressure under the surface of the earth, right? But the issue with alternatives, issue with fossil fuels is that if you burn them, then you are releasing carbon dioxide into the atmosphere. Okay, it was stored in the form of carbon, hydrogen, oxygen complex in the Earth's surface. So if you burn them, you will be producing carbon dioxide. So carbon dioxide is a greenhouse gas. So because of this, a lot of scientists over many years, they have deduced ways to, or alternative ways that we can use fuels, or yeah. Okay, so alternative fuels are basically produced either from biomass. Biomass is either plant or animal material. Okay, and you can produce liquid or gaseous fuels from biomass. Okay, or it can be produced using some other renewable energy sources also. So if you can see in this diagram here, one second. Yeah, so you can see in this diagram here, biomass is there. What is biomass? Biomass is basically plant or animal matter. Okay, so they can be either converted either thermochemically or biochemically. Thermochemically means using heat. Okay, so you either burn it, that is, you can directly combust it, and then you can obtain power and heat, or you can gasify it. Gasification means you are doing combustion, but the main uh, what is required for combustion? Oxygen is required for combustion. I think many of you might know that already. So if there is no oxygen, then the flame will go out. There is no combustion. But what we do in gasification and in pyrolysis is that we heat the biomass. We heat the biomass in the absence of oxygen. Here we give limited supply of oxygen, not enough to completely combust. And here in pyrolysis, what we do is we do it in the absence of oxygen. Okay. So what happens is in gasification, a mixture of gases is formed. Like it's a mixture. It's called synthetic gas, and it is a mixture of carbon monoxide, hydrogen, and traces of methane. Okay, and carbon dioxide. So this is called synthetic gas. So what we can do with this synthetic gas is that we can do a Fischer-Tropsch process. Okay, this is a process used to convert the syngas into liquid, synthetic petrol, okay, and diesel. Okay, or what we can do is there is something called pressure swing adsorption, PSA. Okay, we can separate out the hydrogen from there, and then use the hydrogen somewhere, either in fuel cells or wherever you want it. Or we can adjust the composition, and then there is the synthesis of methanol that we can do. Okay, so or from pyrolysis we directly we can obtain bio oils. Okay, so this is thermochemical conversion. Then when we talk about biochemical conversion, we have transesterification, or hydrolysis and fermentation, or fermentation, crop fermentation. I will talk about these two. They are slightly different. Okay, And then there is one more that is not shown here, that is anaerobic digestion, that is methanation. You can produce biogas. Okay, I think a lot of you might have seen biodigesters producing biogas, right? So biogas is a mixture of methane and carbon dioxide, and then you separate out the carbon dioxide, and then you use the methane for whatever purpose it is. Okay, so there is one more novel way to produce hydrogen, and from solar or wind power you produce electricity and use that electricity in an electrolyzer. So what is an electrolyzer? Electrolyzer is a device to split water into hydrogen and oxygen. Okay, there is an anode and cathode, and then you have water, and then you pass electricity. The water the water splits into hydrogen and oxygen. Okay, so this, in this case, it's called green hydrogen because it is produced using solar or wind power. Okay, if the hydrogen is produced using natural gas, then it is called gray hydrogen. There are different color codings for this hydrogen, and recently the government of India has announced a policy for green hydrogen also. It was literally about, I think about 2-3 months back, okay, to produce a lot of green hydrogen. Next, we'll have a look about the look on the agricultural residues and biofuels. Okay, so there are 3 generations of biofuels, like I just mentioned earlier: 1G, 2G, and 3G. So what is 1G? 1G is first generation biofuel or first generation ethanol. It is produced from crops like sugar cane, corn, or even grains such as rice or something. Okay. Okay, so so what happens is these crops are directly fermented to produce ethanol. Okay, and in second generation, the 2G, what happens is we are producing ethanol or other biofuels from lignocellulosic biomass, that is agricultural residues. Okay, you have your rice, which is your main crop, and then you have rice straw, which is the residue, right, or rice husk that comes after processing. Okay, so we use either of these two, and then or from any other crop, like you have different, even wheat straw and anything you can use. And we need to first do a hydrolysis here, like I had shown in this slide, right? If it is crop, you can ferment it directly to ethanol. If it is a lignocellulosic biomass, that is a residue, then you have to do a hydrolysis first and then do a fermentation. This is because the residue does not have enough sugar for the bacteria to ferment it. So you need to release those sugars by doing this hydrolysis. Okay, and third generation is produced ethanol produced from algae. Okay, so these agricultural residues are byproducts from the agriculture, from rice or wheat, like I just said. And there are primary and secondary residues. So what are primary residues? They are obtained during the harvest itself, like rice straw is a primary residue, whereas secondary residues are obtained during crop processing, like rice husk, for instance, and sugarcane bagasse, because after you remove the juice from the sugarcane, whatever is remaining, that is called sugarcane bagasse. Okay, and advanced biofuels are nothing but these second generation biofuels. So these are produced from the second generation biomass sources. Okay, so that is what is meant by advanced biofuels. So production pathways, as we have already seen, biochemical and thermochemical. So why are we going for biofuels in the first place? So if we look at the final energy consumption, about 17%, yeah, so about 600 million tons of oil equivalent. MTOE means million tons of oil equivalent. Okay, So you have crude oil, right? So if you take 1 million tons of crude oil, the equivalent energy that is this much. So that is the energy measure here, million tons of oil equivalent. So 600 MTOE in 2018, out of which 17% was by the transport sector. Okay, and if you can see in this pie chart, about 94% uh, 94% was contributed by oil products and another 3% by natural gas. Okay, and renewables, it's very less, it's only 1%. Okay, so we have potential here. We have to move away from these fossil fuels and towards renewables, or even towards electric vehicles for that matter. So the transportation emission in India is about 300 million tons, or 0.3 gigatons, right? So it is the third largest after the USA and China. Okay, um, so how much petroleum have we imported in the last few years? So in 2021 alone, we have imported 211 million tons of crude oil with an import bill of $139 billion. I think that's close to 10 or 11 lakh crores. Okay, yeah, it's around 11 lakh crores, I think. So that is the import bill each year for India, and if you can see the trend, it's only increasing. It decreased in 2020 because of the pandemic. Okay, otherwise it is still, it just keeps on increasing. So if this continues, then of course uh, the rupee value will obviously depreciate mainly because of our imports, right? So we need to find a way to reduce these imports, and biofuels can be one of those solutions, because if we blend biofuels with, let's say, bioethanol with petrol, then we can avoid the import of crude oil, right, in the long run. So the consumption of petrol was about 30 million tons in 2021, and it is expected to increase to 35 million tons in the next 3 years, right? And the high speed diesel consumption was about 76 million tons. Okay. Okay. Um, So what is this is something called representative concentration pathways. So what does this say actually? So in the year 2000, this was the primary energy use. So bioenergy was a very less. We have used a lot of oil and coal, right? These two were the most predominant sources of energy. Okay. Now what the study says is that if we proceed in the same pathway that we are going in, okay, they basically proposed a few pathways to limit the temperature rise of the earth, okay, to below 2 degrees Celsius from pre-industrial levels. Okay, but if we continue in this same pathway that we are going, right, up to 69% of the global energy demand will be supplied from fossil fuels, and out of that, industry and transportation will account for almost 60% of the energy consumption. Okay, so what happens is, this is business as usual, RCP 8.5. So I'll explain what these numbers mean shortly. Okay, and if we continue, then we are looking at upwards of 4 degrees Celsius temperature rise, and that is catastrophic. We are trying to limit it to 1.5 or less than 2 degrees Celsius basically. Okay, so this should be our target. So if you can see this scenario, bioenergy is a lot. So this is bioenergy, right? So bioenergy should be predominantly should be predominant in our energy consumption, right? Primary energy use basically. There can be coal, of course, but it should be if you see business as usual in the year 2100, it will reach to around 800 exajoules. So that's quite a lot, right? So what are these numbers 2.5, 4.56 and 8.5? They are called radiative forcing. Okay, it is measured in watt per meter squared. It is the total amount of energy added to the Earth's atmosphere basically from the industrial era, from the start of the industrial era. In this study, they have considered it as the year 1850 and until 2100, how much excess energy has been added into the Earth's atmosphere. So, what are the causes of this radiative forcing? Radiative forcing can be positive or negative. So, if it is positive, that means it's heating up, and if it's negative, that means it's cooling down. So, if you emit a lot of greenhouse gases in the atmosphere, then obviously the Earth will heat up. So, that is a positive radiative forcing. If you plant more trees, then we'll have negative radiative forcing, and so on and so forth. And if you have more clouds, then it is negative. So that way, there are lots of causes for the radiative forcing. Okay. Okay. So what are the consequences of our actions? So if we continue, if we actually go to this scenario, right, which is business as usual, if we continue in the same path, this is what will happen, right? So you remember 2 years back there were bushfires in Australia, and every year in Bangladesh there are floods, and even in India and many places uh, there are unseasonal floods that are happening. So that will only get dire in the future, right? So if we continue in the same pathway, we would have emitted about 7,000 billion tons of carbon dioxide in 90 years. Okay, that is cumulative. So that's a lot, like compared to anything, that's a lot, right? And and then of course we will have a temperature rise of close to 5 degrees Celsius from pre-industrial levels, whereas the target is 1.5 degrees Celsius, right? And the most important thing is that there will be about 1 billion climate refugees, that is 100 crore people, almost about 70%, 80% the population of India. Can you imagine? Okay, those many people will be refugees. There are refugee crises happening due to wars and stuff already, and if you add this to that, if you add these people to that, it's going to be a very hard time for us, right? And of course, we also run the risk of depletion of fossil fuel resources in the near future, right? So there is an opportunity, right? So if you look at this, this shows the life cycle greenhouse gas emissions for vehicles in India. Okay, so fuel consumption, that is the tailpipe emission, accounts for about 65% or almost 2/3 of the vehicle emissions, and fuel production accounts for about 20%, right? So what does this mean? It means that when you're producing the fuel, let's take petrol for instance. So crude oil comes from somewhere in the Gulf or whatever, whichever country. It comes here, it gets refined, and then it is sent to the distribution, the petrol bunks, and then we get our fuel. So that whole process is this 20%. Okay, so out of this 250 or whatever it is grams carbon dioxide emission per kilometer, 20% is from the fuel production, and about 65% is due to the consumption. That is, you are burning the fuel in your vehicle, right? And the tailpipe emission accounts for about 65%. Okay. So in India, the petrol, diesel, and CNG vehicles will they emit anywhere between 200 to 300, 320 right? Grams of CO2 per kilometer that you drive. So for each kilometer that you drive, so much is the emission. Okay, let's say 250 or 300 for diesel almost. Okay, so if you see, there is an opportunity to reduce over here. This 65% can be reduced. How can we reduce that? But we can use biofuels, because biofuels are considered carbon neutral. Why are they considered carbon neutral? First, because when they are growing, they absorb carbon dioxide, because they are plants, right? So they need carbon dioxide to survive. Okay, so because of that, they absorb carbon dioxide, and that carbon dioxide is stored in the plant's body as carbon, right? And when you burn them, it's the same carbon dioxide that comes out. So it is considered carbon neutral. Okay, so this fuel consumption, the 65%, will come down when you use biofuels. Although there will be some emissions over here in this 20%, because we also have to consider the transportation of biomass, the transportation of biofuel. Okay, all of these we have to consider. There won't be much change in these two numbers, because the absolute numbers, I don't mean the relative percentages, the absolute numbers, there won't be much changes, because the vehicles are going to be more or less the same, right? So here are some of the policies, right, that the government has enacted, like enacted in the recent past. So from 2003, okay, so you have the ethanol. Ethanol has started way back, about 20 years back itself, but we have not actually gotten anywhere. Like we still are at about 10% blending, okay, despite having so many ethanol programs. And I'll come to that. I'll explain why that happened, all right, why these policies failed. So from 2003, see, the target was 5% in 2003, 5% ethanol blending with petrol. Okay, the second was biodiesel. So biodiesel can be produced in two ways. One, there can be a plantation. There is a plant called Jatropha curcas. You can plant that, and the seeds of that plant is quite oily. You can extract oil from the seeds and then convert it into biodiesel. Or the more recently, what they have done is, from used to cooking oil, that is, you use oil, right, for frying and all that. So once you use that, maybe once or twice, you cannot reuse it. It's not very healthy to reuse the same oil. So what some researchers have done, they have collected these oils from restaurants and then converted it into biodiesel. And they have even run a plane, an aircraft, SpiceJet aircraft, if I am not mistaken, using this biodiesel. All right, not the complete one, just one engine of that SpiceJet aircraft ran on a blend of this biodiesel, right? Then, of course, there are many ethanol policies in 2006, 2007, and then there was a national policy on biofuels in 2009, which envisaged about 20% blending for both ethanol and biodiesel by the year 2017, but that also did not happen. And then the most recent were the national policy on biofuels in 2018 and ethanol blending program in 2020. So what happened here is, they envisaged 20% by 2030, okay, and for biodiesel about 5%, okay, and this is compressed biogas from municipal solid waste. I told you about the anaerobic digestion, right, through that pathway. So about 40% compressed biogas in natural gas by 2025, okay. But in the ethanol blending program, what they did is they advanced this target, the 2030 target, to 2025 by 5 years. and we are currently at 10%, and we are well within target to reach 20% by 2025. And the latest policy is the National Hydrogen Policy, where I explained about the green hydrogen, right? So the government is planning to build a lot of green hydrogen plants, okay? And we have to produce, the target is to produce 5 million tons of green hydrogen by the year 2030, okay? Now we come to the other side of 1G ethanol. So we saw that, okay, they're carbon neutral and all that, but there are some disadvantages as well, for especially for the first generation ethanol, okay? So if you divert food grains like corn, like sugarcane or rice to ethanol production, then what will we eat? Okay, so this is a question that has been asked over the last 30-40 years, since globally this is right. So about 50 years back in Brazil and USA, they started blending ethanol produced from sugarcane and corn, okay? And that happened during the oil crisis in the 1970s. That is, the oil producing countries, they refused to give crude oil to US and other countries. So these countries came up with this idea of blending ethanol with petrol, okay? So in India today, the blending is 10%, okay, and we are targeting 20%. It is achievable, but most of this is from sugarcane molasses juice, corn, damaged grains. This is fine. You can use damaged grains to produce ethanol. That's fine. But the most important is the government has allowed using surplus grains in stock with the Food Corporation of India. Perfectly good food grains are being used for ethanol, okay? Maybe they are surplus now, but in the future, if they require it for hunger eradication or some program, then this is going to be an issue, right? And like I said earlier, like from 2003 onwards, we have had a lot of ethanol policies, but the ethanol program never took off as spectacularly as it did in the last 10 years, okay? That's because what the government did is they cleared bottlenecks with respect to feedstock procurement. What they did is they announced that different feedstocks can be used to produce ethanol. Feedstock means different biomass sources. So here you can see molasses, juice, corn, damaged grains. These are different biomass sources, right? So earlier there was only molasses, okay? So only molasses could be used, and so they cleared that bottleneck. And the second is differential pricing. So what is differential pricing? So if you produce ethanol from let's say feedstock A and feedstock B, the cost of ethanol will be different. The cost that you need to invest, or the production cost of ethanol, will be different. So based on the feedstock itself, the government provides different prices. Like when the government buys it from these refineries, they provide different prices to different ethanol of different feedstock, okay? So that is called as differential pricing, okay? So because of all this, we have gone from 0.67% blending in 2012 to 10% right now. We achieved this, I think, just a couple of months back, and we are well within reach of 20% target in 2025, okay? But of course the question remains, when we are using first generation ethanol, what do we use it for? Food or fuel, right? So let's talk about electric vehicles, okay? So this is the hot topic right now, okay? Everyone is talking about how electric vehicles are going to be a game changer and all that. And by 2040, of course, electric vehicles will make a huge chunk of all cars on the road. But are there any benefits Okay, so what are the pros? Of course, reduced dependence on petroleum and zero tailpipe emissions. So you don't have any emissions here. So there are no local emissions, but what are the disadvantages? You need lithium ion batteries for electric vehicles, and lithium reserves are found only in a handful of countries you can see here. Okay, Bolivia, Argentina, Chile, USA, Australia, China. Okay, so essentially, instead of depending on, let's say, Gulf countries or Venezuela or Russia for oil, we will be dependent on all these countries. Okay, for to procure lithium. Okay, so our situation, it's just like, okay, instead of importing oil, we are importing lithium. That's it. Okay, so it's not going to change much. Okay, the second is generation of e-waste from lithium ion batteries. The batteries have a life cycle, and at the end of this life cycle, they have to be disposed. So we need to do something about all the e-waste that will be generated. Okay. Third is, of course, right now, but this is only currently, okay, the non-availability of charging infrastructure. That can be changed, of course, if the government brings in a lot of policies and such, we can have an extensive charging network all over the country. And the final point is that electric vehicles contribute to greenhouse gas emissions too. Okay, it's not that just because there are no tailpipe emissions that there are no greenhouse gas emissions, and that's about, I think, half that of the petrol and diesel vehicles, but still it's still a significant chunk, right? Okay, so now we have come to the end of this presentation. We will go to the questions shortly, but in case you have any doubts regarding any of the, yeah, if I was clear with whatever I said, or if you have anything to ask me, you can just ask me right now before we go into the questions. There are no questions? You're able to hear me, right? Or am I not? Okay, so we'll go into the questions now for this week. Okay, the first question is, what does the 8.5 in RCP 8.5 stand for? So RCP is representative concentration pathway, and 8.5, that number I had just told you that in one of the previous slides. Okay, your options are A, increase in surface temperature of the earth; B, percentage increase in the concentration of greenhouse gas emissions; C, radiative forcing; and D, increase in absolute amount of carbon dioxide in the atmosphere. So do we have answers yet? Okay, let's wait for some more answers before I proceed to the next question. Okay, so we have some answers. All right. Next, which of the following statements are true? A, second generation biofuels are produced using non-food agricultural residues like rice straw. B, second generation biofuels are also called as advanced biofuels. C, first generation biofuels are produced directly from the crops. D, all of the above. All right, I'll be giving you the answers. You can just write them down. I'll give you the answers next week like I usually do, right? Okay, all right. Okay, next. Question number 3 is which among these biomass to biofuel conversion pathways comes under the thermochemical conversion? Okay, A, fermentation, B, anaerobic digestion, C, pyrolysis, or D, none of the above. All right. Okay. 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 Fine. D. Question number 4. Sorry. The Indian government allowed the use of multiple feedstocks and introduced differential pricing to ensure the development of ethanol industry in India. What is meant by differential pricing? Option A is buying ethanol at different rates based on the feedstock used for production. Option B is reimbursing the ethanol production companies a part of the capital cost of the ethanol plants. Option C is providing ethanol to end consumers at subsidized prices, or D, none of the above. You want to have a look again? Should I go back to the question? I'll read the question again in case you're not able to understand. The Indian government allowed the use of multiple feedstocks and introduced differential pricing to ensure the development of the ethanol industry in India. What is meant by differential pricing? So A is buying ethanol at different rates based on the feedstock used for production. B, reimbursing the ethanol production companies a part of the capital cost of the ethanol plants. C, providing ethanol to end consumers at subsidized prices. Or D, none of the above. Do we have answers? You have different answers here. I had covered differential pricing just before this when I was talking about the policies, if you can recall that. Okay. Do you want me to go back to that slide again, where we talked about the ethanol policy and how we are at 10% now? And yeah, okay, I'll do that. Maybe I was not clear there. So here, okay, so we were at 0.67% blending level in 2012. Now we are at 10%, and we are well within reach of our 20% target in 2025. But how did this happen? Okay, for you have seen, I think, yeah. See, from 2003 onwards, we have had ethanol blending policies and programs and all that. But until 2012, we have not had much success in the ethanol program. So why was that? There were bottlenecks with respect to feedstock procurement. So the what the government did is the government allowed the ethanol producers to use different feedstocks, like like here molasses or sugarcane juice or corn, damaged grains, even second generation feedstocks like sugarcane bagasse, and so on. Okay, but the issue with this is that if I let's say I am producing ethanol from some feedstock A, and you are producing ethanol from some feedstock B. The cost that I will incur because of the feedstock of my choice, or because of the feedstock available to me, will be higher than the cost incurred by you. Okay, let's say for example, so I'm incurring a higher cost and you are incurring a lower cost. So if the government says that I'll procure ethanol at the same price from both of you, that means I am at a loss and you are making a profit, right? So what the government did is that based on the feedstock used, okay, the government said that okay, I'll procure from each of you at different prices. Okay, so if from me they've procured at, let's say, 60 rupees per liter, from you they'll procure at 55 because you have incurred lesser cost, because you have chosen a different feedstock. Okay, so I hope I'm clear here. So did you understand now what differential pricing means? Okay, so now you'll be able, yeah, I'll go back there. Yeah, now I'll just read the question again. So the Indian government allowed the use of multiple feedstocks and introduced differential pricing to ensure the development of the ethanol industry. What is meant by differential pricing? A is buying ethanol at different rates based on the feedstock used for production. B is reimbursing the ethanol production companies a part of the capital cost. C is providing ethanol to end consumers at subsidized prices, or none of the above. Let's go back here. Please read the question again. Can you? Okay, I'll just quickly explain that again. See, I am using a different feedstock, someone else is using some other feedstock. Okay, let's say I am using sugarcane juice or sugarcane molasses. You are using, let's say, bagasse or something else. Okay, so the cost that I will incur is different, the cost that you will incur is different. So that if the government buys it at the same rate, okay, let's say the government fixes the rate of ethanol at, let's say, 60 rupees per liter, and my cost is, let's say, 59 and your cost is 57. So you're making 3 rupees, I'm making only 1 rupee per liter of ethanol. So what the government did is, to ensure that everyone gets the benefit, all that people don't lose out on this because of, yeah, so because of the feedstock chosen, the government said, okay, I will procure it at different rates from each of you based on what feedstock you have chosen. Okay, so that is differential pricing. So do we have answers now based on what I have just explained? One of you have got it right, so let's see if everyone else does. Yes. Okay. Okay. So I was clear, right, with my explanation now? I hope so. Yeah. Okay. So I'll go to the next one. Okay. Why is biomass considered a carbon neutral source of energy? Okay. A. Burning biomass does not emit any CO2. B. The CO2 emitted during combustion of biomass does not cause global warming. C. The CO2 emitted during combustion of biomass is the same amount of CO2 absorbed by the plant during its life using photosynthesis, and hence does not add any new CO2 to the atmosphere. Or D, none of the above. We got the question right? Sorry. Okay. 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 Next is electric vehicles have no tailpipe emissions. However, these vehicles also contribute to GHG emissions, greenhouse gas emissions. How? A is manufacturing of electric vehicle components and maintenance contributes to emissions. B, a huge chunk of electricity is still produced using coal in many countries. Hence, using grid power to charge the EV contributes to the greenhouse gas emissions. C, during operations, the lithium ion batteries contribute to CO2 emissions. Or D, both A and B. Okay. All right. Okay. Oh, you haven't seen the question. I'll just 1 second. Yeah. So electric vehicles have no tailpipe emissions. However, they also contribute to the greenhouse gas emissions. So how do they contribute to greenhouse gas emissions? A is you have the manufacturing phase of the components which contribute to emissions, or B is that when you're charging the electric vehicles, you're using electricity. That electricity comes from coal power plants, okay, in many countries. So because of that, the coal power plants, of course, they emit CO2, right? So that is the second reason. Third is during operation, the lithium ion batteries emit or contribute to CO2 emissions. Or D, both A and B. Question is clear, right? All right. Okay. Next question is, why is the sustainability of first generation bioethanol under debate despite its potential to reduce the need for fossil fuels? Okay. The question is clear. Why is the sustainability of first generation bioethanol under debate despite its potential to reduce the need for fossil fuels? A is, despite being carbon dioxide neutral, there are emissions of methane and nitrous oxide from the agricultural fields during the crop cultivation phase. B, I haven't told you about this one actually. So, for example, you have rice. So, when we flood, if you have seen rice fields, they are always flooded, right? So, because of that, what happens is there are microorganisms in the soil that, and these microorganisms release methane. Okay, methane is 20 to 25%, 20 to 25 times more potent greenhouse gas than carbon dioxide. And same with nitrous oxide. How do we emit nitrous oxide in when we are cultivating? Because we have nitrogen fertilizers. You have urea, right? So when you apply urea to your field, it gets oxidized eventually, and then nitrous oxide is released. All right. So this is a point that I had not mentioned. So now I've just told you about this. Okay. So your option B is diverting food grains for the production of ethanol might create a food shortage. Option C is vehicle parts compatible with higher percentage of ethanol in the higher percentage of ethanol are not commercially available yet as of now. Or D, all of the above. Right. You need to see the question again. I've only got one answer, 2 now. Okay. Okay. Do we have more answers? All right. I'll just do the question once more. So why are we talking about the sustainability, whether first generation bioethanol is sustainable or not? Okay, because first is there are emissions of methane and nitrous oxide from the agricultural fields. Okay, and methane and nitrous oxide are more potent greenhouse gases than carbon dioxide. So okay, so it makes more sense to burn the methane and then emit just carbon dioxide to the atmosphere. Okay, that's how it is, because that's how dangerous methane is if emitted to the atmosphere. So okay, option B is diverting food grains for production of ethanol might create a food shortage. Option C is the vehicle parts compatible with ethanol or higher percentage of ethanol are not yet available in India commercially. So for each blending percentage, let's say 10% blending, we talk about 10% blending now. We need to have parts that are compatible, the engine parts and everything compatible with this 10% ethanol. Okay, so or D, all of the above. All right. Okay, next we have a numerical here. Okay, you can work it out, you can just work it out, and don't have to answer right now, or we can discuss this in next week also. So see, the ethanol blending program, as I just told you, the government envisages a 20% blend of ethanol by the year 2025. So in that year, the estimated consumption of petrol is 3.5 crore tons, or 35 million tons of petrol will be consumed. Calculate the amount of ethanol needed to be produced in 2025 to satisfy this demand. So I have given you the density of petrol. Okay, and the hint is you use density, the formula for density, mass upon volume. Okay, and the other unit conversions, you have 1 meter cube is 1000 liters and 1 ton is 1000 kg. Okay, so you have the options here. Can someone tell me how to proceed with this? You don't have to tell me the answer right now, just tell me how to proceed if anyone knows, or else I'll tell you myself. Okay, is the question clear? The mass of ethanol, wait one second. Okay, see, the percentage is volume. Okay, it's not mass. I need to mention that also. The 20% that I have mentioned, yeah, although you won't be very off even if you use mass, because the densities are quite closer together. So yeah, sure. Right, so 20% blend of bioethanol by the year 2025, and 3.5 crore tons of petrol will be consumed in that year. Okay, and this 20% is volume, not mass. Okay, so you need to calculate the volume of ethanol in liters to be produced in 2025 to satisfy this demand. Okay, exactly. So I have, exactly, that's it. Okay, so first you have to convert the petrol mass into volume, okay, the 3.5 crore tons. So how will you do that? How will you convert it into volume? Can you tell me? By the, yeah, absolutely. So use the density formula, okay. So then the density formula is mass upon volume. Density equals mass upon volume, right? So you use that to convert. So you need the volume of petrol, okay. So volume equals mass upon density from this formula, okay. So you have the mass, you have the density, so you will get the volume, and then 20% of that is your ethanol. That's it. Okay, it's a simple calculation. Okay, so you can calculate and then you can let me know by, I mean, next week anyway we are discussing this. Okay, so that's it. We are at the end of today's lecture. Okay, so if you have any questions, you may let me know. First question of last week. Answer of the first question. Okay, came just here, right? Yeah. So A is equitable, economic and social. B is bearable, social and environment. C is viable, economic and environment, and D is sustainable. Okay. So you want the fifth question, Koshish, right? You want fifth question of this week, right? Okay. So why is biomass considered a carbon neutral source of energy? So A, burning biomass does not emit any CO2. B, the CO2 emitted during combustion of biomass does not cause global warming. C, whatever CO2 is absorbed by the plant during photosynthesis during its lifetime is the same amount of CO2 emitted while burning its body. Basically, that's what this means. Okay, or D, none of the above. Okay, you got the question right. All right. Okay, do you know the answer to the question? Oh, all right. Thank you. Okay, you already mentioned it. Okay. Fine. Are there any more questions or any doubts? Question 8. Okay, I'll do it. Okay. So the government says that we have to blend 20% ethanol in petrol by the year 2025. So in 2025, the consumption of petrol will be 3.5 crore tons or 35 million tons. All right. I need you to calculate the volume of ethanol in liters required to be produced in 2025 to satisfy this demand. Okay, and this 20% blend that I am talking about, that is on volume basis, that is not on mass basis. Okay, the hint is you can use the density formula, that which is mass upon volume, and you have some conversions here, like 1 meter cubed is 1000 liters, or 1 ton is 1000 kg, and all. Okay, so is it fine? Any more questions? If there are no further questions, I'll just stop presenting right now. Okay. All right. So please let me know if you couldn't understand something, or would like me to do something differently. Please let me know. Okay. I hope all the concepts and all the graphs that I explained this week was clear to you. They were clear to you. Yeah. Okay. So if there are no more questions, then we'll disperse for the day, and I'll meet you next week. And as always, please don't forget, on Tuesday you have another session, okay, 7 to 8, so please attend that also. And there's one more thing that a couple of things actually. First is, some people had asked for the link, right, to the YouTube video. That will be shared by NPTEL in the course page itself, so you please keep looking for it. So they told me that I cannot share it in the discussion forum. Okay. And the second thing is that Google Meet allows only about 100 people in each session, so please join. I'll be here from 5:55 onwards. I'll give you the answers next week. Okay. Next week I'll give you the answers. Okay. So yeah, I was just saying that you please join at around 5:55, because I mean join early, because only 100 participants are allowed. Okay. So the sooner you join, the better your chances will be of actually getting through, right? Okay. So thank you so much for listening to me patiently. I know uh, we are 15 minutes past time, so thank you for your patience, and I'll see you all next week. All right. Bye. Have a great weekend.